We can use our sum and difference formulas to solve equations. So in the example that we see in front of us here, we've got a string of sines and cosines that are all linked together by that subtraction symbol. And so hopefully we can identify this as being the sine of alpha minus beta, the difference formula for sine, where alpha is 5x and beta is 3x. So here we can work backwards on this example and combine that string of sines and cosines into a single sine of 5x minus 3x. And then we still equal 1/2 on the other side. And so now we can rewrite this as sine of 2x equals 1/2. And now we have an equation that we can solve using our techniques from our solving trigonometric equations section. So in order to get the x out from inside of the sine, we're going to have to take the arc sine of both sides. So we're going to have 2x equals the arc sine of 1/2. From there, we need to apply the definition of arc sine. So we'll still have this 2x equals. So if we recall from those solving equations notes, the definition of arc sine is the inverse sine of 1/2 plus 2 pi n. And then we have the companion pi minus the inverse sine of 1/2 plus 2 pi n. And so now we need to find what is that inverse sine of 1/2. So if we go to our unit circle, when the y coordinate is 1/2, that means we're at pi over 6. So we have pi over 6 plus 2 pi n. And then we also have pi minus pi over 6 plus 2 pi n. And so then the last thing we've got to do, because right now we have 2 in front of the x, it's not just x, so we've got to divide by 2, or if instead of dividing by 2 we could multiply by 1/2 on both sides. And so we've got to distribute that through to everything in our answer set. So we're going to end up with x equals pi over 12 plus pi n, so pi over 6 times 1/2 is pi over 12. And then the 1/2 multiplies the 2 pi n, so we're just left with pi n. And then pi minus pi over 6 is 5 pi over 6. But then we have to multiply that by 1/2, so we get 5 pi over 12 plus pi n. And so this here is our infinite solution set for this equation. And then, as is our usual, we're either trying to find all the answers that are between 0 and 2 pi, or in this case, we are asked for the first 4 positive values. So we can go ahead and roll through those. So we're going to have x equals pi over 12 is our first, if I'm plugging in 0 for n into each of these. And then 5 pi over 12 is our second. And then if we add pi to both of these, pi over 12 plus pi, so now we're adding 1 pi, we're putting in 1 for n, so pi over 12 plus 12 pi over 12 is 13 pi over 12, and then finally 5 pi over 12 plus pi, or 5 pi over 12 plus 12 pi over 12 is 17 pi over 12. And so now we've got the first 4 positive values of x that work in this equation. So this is just an example of how we can use that difference formula in reverse. So we take the expanded expression, combine it into a single sine, and then we can use our arc sine and the subsequent definition of arc sine to solve the equation. In our last example, we're going to see how we can use the difference formula, in this case for cosine, to verify an identity. So the identity that we're going to verify is the cofunction identity. Now, we were introduced to these cofunction identities in our very first lesson involving trigonometric identities. We don't use these very often, but here we see it pop up, this idea that cosine of pi over 2 minus x is equal to sine of x. So we're going to verify that that is indeed the case. So we're going to treat the pi over 2 as our alpha, and x is going to be our beta. So what we really have here is kind of a cosine of alpha minus beta. And so we're going to use the identity, use the formula that we have up above at the top of our notes to expand this expression. So we're going to see cosine of pi over 2 times the cosine of x plus, opposite of the positive negative sign in this particular formula, sine of pi over 2 times the sine of x equals sine of x. We want to verify that this is indeed the case. So the cosine of x and the sine of x, we can't really do much with those, but cosine of pi over 2 and sine of pi over 2, we can evaluate those. Those we can use the unit circle to figure out what those results are. So cosine of pi over 2, if we look at the unit circle, the x-coordinate at pi over 2 is 0. So that means this is going to equal 0. And then sine of pi over 2, same location, but now the y-coordinate is 1. Sine is the y-coordinate on our unit circle, so we're going to replace that with a 1. So what we have here then is 0 times cosine of x plus 1 times the sine of x equals the sine of x. And so then finally we can see 0 times the cosine of x, that just disappears. 1 times the sine of x equals sine of x. So we've got sine of x equals the sine of x. And so we have indeed verified this cofunction identity. So we can give ourselves a little check. Boom.